Okay, moving on to some examples of solving convex mirror problems, and the tip of the day is be careful about your signs. Respect thy negative, as Mr. Ripley would say. If you don't get that sign convention down, it's going to come back to bite you, so be real careful. Keep your notes handy if you need them. So, if you still have that spoon that I had you get out in the previous videos, because you forgot to take it back to the kitchen, well, grab that sucker and now look at your reflection in the back side of it. You are going to see yourself small and upright and all of these things. So let's say that your spoon has a radius of curvature of 36 centimeters and you are holding the spoon 20 centimeters away from your face, and we want to figure out where that nice, beautiful image of you in the back of your spoon is. So we're going to use our 1 over dO plus 1 over di equals 1 over f equation. We're given the object distance, so we've got 1 over 20, and as I mentioned previously, you can leave things in centimeters as long as all the units match, then you're good. The image distance is what we're going to solve for, so we'll leave that there as the unknown. And the focal length, well, it didn't give us that, but it gave us the radius of curvature, and the focal length is half of that. So that is 18. And as I mentioned in the previous video, focal lengths for convex mirrors are always negative, so you got to have that negative sign or you will not get the right answer. Alright, from here it's a bit of algebra, and you can solve for the image distance, which comes out to be negative 9.47 centimeters. And we would expect it to come out negative because we know that we have a convex mirror. Here's your smiling face. And so the image is going to be here in the, I guess it should be smaller. Anyway, oh my goodness, I don't know what's going on there. Let's get rid of that. Okay. Smaller image of your face in the mirror. And so because the image is on the other side of the mirror, that's got to be negative. That makes it a virtual image. Whenever you have negative image distances, that tells you it's virtual. I already told you it's upright, but if you're not sure, you look at your magnification equation and you want to see if this is positive or negative. Positive is upright, negative is inverted. And so we've got negative di over dO. dO was positive, di was negative, so if we throw another negative in there, these guys go away and become positive, and so that just shows you that it is upright. Okay, one more. Image of a distant mountain is virtual and quite small when viewed in a curved mirror. Image appears to be 12 centimeters behind the mirror. What kind of mirror is it? Well, obviously it's a convex mirror, because why would I be doing a concave mirror example in the convex mirror video? So we know that, but also because the image is virtual and it's a distant object that we are making an image of. Concave mirrors can only make virtual images, if you remember, if you are closer than the focal point. So here's our object. That's the only time it can't focus the rays and when you'll get your virtual image. But that's not the situation here. We're distant, so the only way we can get a virtual image is if we have convex mirror, and then we'll get our shrunken virtual image. Okay, so there is the answer to that part. Okay, then we want to know the radius of curvature, which tells us we've got to find the focal length first. So we use the one equation we almost always use, 1 over dO plus 1 over di equals 1 over the focal length. If we have a distant mountain, that doesn't give us our object distance, but whenever you see this in a problem or on a test, distant means it's far enough that the lines are parallel, and we can treat that distance as infinite or infinity. Okay, so we want to find our image distance. Oh no, that was given, sorry. We want to find the focal length. So 12 centimeters. Now, since it's behind the mirror, that tells us about the sign. Again, you got to be real careful with these signs. You have negative 12, which means this just goes to 0 because you're dividing by infinity. So the focal length is just equal to negative 12, and the radius of curvature is twice that, so negative 24 centimeters. And we wanted this to come out negative, right? Because we are dealing with convex mirrors. If you don't remember these rules, if you remember your sign conventions, then you can always interpret your answers to figure out whether things are convex or concave or real or virtual and all of those fun things. Okay, see you next time.